Let's go to look at one more example from section 10.1 on goodness of fit tests. So this is problem 4 in the homework. And it says a researcher claims that the number of homicide crimes by season is uniformly distributed. To test the claim, you randomly select 1,199 homicides from a recent year and record the season when each happened. Okay, the table shows the results. So at a level of significance equal to 0.01, test the researcher's claim. Okay, so in the first part of the question, we are stating the null and alternative hypotheses. Okay, so according to the null hypothesis, the distribution of the number of homicide crimes by season, okay, is uniformly distributed. Okay, that's what it says in the problem. And then the alternative hypothesis would be that the distribution of the number of homicide crimes by season, okay, is not uniformly distributed. Okay, and then which one of the hypotheses is the claim? All right, and it would actually be the null hypothesis. Okay, so based on that information, we want to calculate the test statistic. Okay, so let's go ahead and copy the table into StatCrunch. Okay, so there's the table. So the season in the first column and the frequency for each season. Okay, so these are the observed frequencies. All right, so let's go to the stat menu. Go to goodness of fit, and then select chi-square test. Okay, so the observed frequencies are in the frequency column. Okay, so unlike the other example we did, okay, the expected frequencies were calculated according to the percentages, right? That's how we calculated the expected frequencies, right? But actually, StatCrunch did it automatically, right? And we selected the column that contained the percentages. Okay, but in this case, the problem just says that we expect or we believe that the number of homicide crimes per season is uniform, meaning that we should expect the same number of homicides per season. Okay, so what that means is we're going to select the second option here. So where it says expected, select all cells in equal proportion. And StatCrunch knows that among the 1,199 homicides that we have in our sample, right, it knows that it's going to divide that number of homicides in our sample by the number of seasons to get the expected frequency for each season. Okay, so it's going to do all that automatically, so you don't have to. All right, and we're going to go ahead and click compute. Okay, leaving the display expected, okay, which is already pre-selected. Okay, and it tells you a summary of your sample. So the number of homicide crimes that are included in our sample, the degrees of freedom. Right, so there were 4 categories, 4 seasons, so the degrees of freedom is 4 minus 1, which is 3. And what we're looking for is that test statistic. Okay, and we're going to round it to 3 decimal places, so 2.824. Right, so that 4 gets rounded up to a 5, so 2.825 would be our test statistic. All right, and then it's also asking for the p-value, which is this number here. So 0.4194 is that p-value. So it gives it to you to 4 decimal places. All right, but let's round it to 3. So it would be 0.419 rounded to 3 decimal places. Okay. So what we can do is compare the p-value to the level of significance. Okay. to make a decision regarding the null hypothesis, right? On whether to reject the null hypothesis or fail to reject the null hypothesis. So very clearly, our p-value 0.419 is larger than our level of significance. Okay, so we will reject the null, fail to reject, sorry, right? If it's larger than your level of significance, if the p-value is larger than your level of significance, right, you fail to reject. But if it's less than the level of significance, you reject the null hypothesis. Okay, in this case, we fail to reject the null hypothesis. So the way that we word this, which can be sometimes a little tricky, is that there is not enough evidence at the 1% level of significance to reject the claim, okay, that the distribution of the number of homicide crimes by season is uniformly distributed. So again, this can be a little tricky if you're not careful, right? So because the claim of the problem is represented by the null hypothesis, all right, and we failed to reject the null hypothesis, right? That means that there's not enough evidence to reject the claim represented by the null hypothesis. Remember that the claim being that the number of homicide crimes per season is uniform. Okay, so the way that this is worded is there is not enough evidence at the 1% level of significance to reject the claim that the distribution of the number of homicide crimes per season is uniformly distributed. Let's go and check our answer. All right, and that completes question 4. So hopefully the previous example in the previous video and then in this example, this video give you enough information to complete the homework in section 10.1. Thank you for watching.